Hi, so in this video we'll be covering 2.15, which is solving inequalities of the IB AA course, and this is only for HL, so if you're SL then you do not have to worry about this video. So when we're doing inequalities, we kind of just have two main things. It's either we are solving graphically or solving analytically, and in this video we'll take a look at both of these. So solving graphically, let's say we have f of x is equal to x plus 1 and g of x is equal to 3 minus 2x. And over here we need to find the x values for which f of x is smaller than g of x. So basically this is our inequality and this is what we're finding. For what values of x is this function smaller than this function. So first what we need to do is graph both the functions on the same set of axes, and we can do this with our graphing calculator. So when we graph it, the graph will look something like this. So we can see that the point of intersection is at 2 by 3 and 5 by 3, which is 0.67 and 1.67 in decimal form. So that's our point of intersection. And now we can check which side of 0.67 has f of x below g of x. So f of x is the blue function and g of x is the red function. So for what side of 0.67, so either to the left of 0.67 or to the right of 0.67, is the pink function greater than the blue function? And we can see that it's towards the left. Towards the left of 0.67, we have the pink function greater than the blue function. This is a set of values for which g of x is greater than f of x. So we can write this down as x plus 1 is smaller than 3 minus 2x when x is smaller than 0.67. Because towards the left, we're kind of looking at f of x, we're kind of looking at x for these values. So that's smaller than 0.67. So this is how we would write down our solution, or you can just write down this part. Let's say we have more than one intersection point though. So, okay, so let's say we're given these two functions, and the green function is f of x, and the blue function is g of x, and we basically follow the same process where we graph this on our graphing calculator and find the intersection points. So this has 3 distinct intersection points, and what we can do from here is basically the question is asking us to find where f of x is greater than or equal to g of x. So where e to the power of negative x squared plus 1 is equal to g of x. And now what we can see is f of x is the blue function, right? So we can look we can split up the domain from each intersection point. So we can look at from negative infinity, we can look at it from negative infinity to the first intersection point, which is here. And we can see that over here, the blue function is greater than the green function. So this is a valid domain, right? And from this intersection point to this intersection point, between these two over here, we can see that the blue function is smaller than the green function. So this is not where f of x is greater than or equal to g of x. And then when we look at the next domain from negative 0.435 to 1.1, we can see again that the blue function is greater than the green function. So this is part of our domain that we're looking for. And finally, from 1.1 to infinity, let's say, the blue function is smaller, so this is not part of the domain that we are looking for. So to give the solution, what we can write is x has to be smaller than or equal to negative 1.09, and x needs to be between 1.10 and negative 0.435, because smaller than or equal to negative 1.09 is anywhere here, and then from between 1.1 and negative 0.435 is here. And these are the two domains that we just saw that were valid for what the question was asking us. And that is it for solving graphically. We just need to plot it in our graphing calculator and find the intersection points. Next, what we can do is solving analytically. So in order to solve an inequality, something like, if we're given something like f of x is smaller than or equal to g of x, and we need to find, solve this inequality, we can try to simplify it into the form of f of x minus g of x is greater than or is smaller than or equal to 0. And this could kind of be our quadratic, and we've learned quadratic inequalities before, so we can solve it similar to that. So let's look at an example. Let's say we have f of x is equal to 2x squared plus 3x minus 1, and g of x is equal to 2x plus 3, and the question is asking us to solve f of x is greater than or equal to g of x. So what we can do is rearrange it into the form that we just talked about and say that 2x squared plus 3x minus 1 minus 2x plus 3 is smaller than or equal to 0. And then we can simplify this. We would get 2x squared plus x minus 4 is smaller than or equal to 0. And now what we can do is plot it on a graph. So let's make a small number line. Let's quickly just sketch over here. And we have 1.7 and negative 1.7 and 1.2. And let's just draw our curve. So we're getting this negative 1.7 and 1.2 by finding the roots of this quadratic. So once we get that, we can draw a small number line, and then we can check. So we can check it. So we can check from this domain, and this domain, and see if the value is positive or negative. So from this domain, we will get a positive value. From this domain, we would get a negative value, and for this domain, we would get a positive value again. So from the sign diagram, we can conclude that the solution for this would be 2x squared plus x minus 4 is greater than or equal to 0 when we are in the domain of negative infinity to negative 1.7 union 1.2 to infinity. This would be closed brackets, and this would be an open bracket because infinity cannot be defined. So that's kind of how we do it analytically. And otherwise, we can again just look at a graph, and so we can simplify and graph it, but that would kind of, that's a similar method into what we just looked at, which is solving graphically. Just an exam tip is that you can use a graphing calculator to solve the inequality directly in the exam. You don't have to do it all manually, but yeah. Thank you. That's it for this video.